Hello everyone, I'm going to present the following paper, Energy Efficiency on Edge Computing, Challenges and Vision. This is the collaborative work among my colleagues in KSU and also my undergraduate students, Taylor and Charlie. I am the presenter, Dr. Kun Suo. As we know, in recent years, on one hand, the IoT is growing extremely fast and more applications are moving to the edge due to the cloud problems such as long latency, bandwidth shortage, privacy issues, and network instability. However, on the other hand, the power efficiency and energy sustainability become one of the most important factors for any type of edge computing. As the edge computing has been widely used in many scenarios, next we will go in to discuss 5 typical applications of edge computing and analyze the control and challenges of energy consumption and further discuss the possibility and their direction. First, let's talk about the smart grid. So the smart grid is a vision of traditional power grid integrating with the green and renewable technology. However, there still exists a certain degree of energy inefficiency inside. First, in terms of the grid operation, most of the data is still separated and the real-time sharing is not strong. And second, various smart terminals collect a large amount of data inside and the quick response to the changes in demand is insufficient. And third, as the new scenarios appears and become more complex, and there still exists a lot of energy waste in such smart grid. Next, smart homes can provide a highly efficient human-computer interaction, safe control, and configurable functions. As the number of devices and features increase, the smart home itself will also generate more energy consumption. We found that the energy consumption of smart homes mainly comes from 3 aspects: the smart device itself, the communication system, and the control system. Smart cities currently use the cloud computing and tremendous IoTs to connect the physical buildings, information systems, and commercial infrastructure. With many sensors and equipment, the energy consumption will also increase significantly. And also in operating the smart cities, collecting, processing, communication, and using all these data will also generate a lot of power consumption. The electronic vehicle is also a new type of edge computing in our life. The main problem of the EV today is its low battery energy density and the short driving range. Although there are many innovations today for the EV, the energy efficiency in the electronic cars still has a long way to go to be truly efficient. Lastly, the virtual reality is one of the latest directions of edge computing. However, for real-time algorithm built for the VR and AR applications, it will consume lots of energy. Although new hardware and software have improved the energy consumption in recent years, so a VR with very good user experience and very low power consumption is still not ready for millions of users today. Next, we will discuss the state-of-the-art technologies and efforts to address the energy inefficiency from the earlier case studies. One of the reasons of the energy inefficiency on edge is the overcomputation. The edge nodes are constrained by their lack of powerful processing power due to their compact form, so the computation offloading is one solution to this problem by offloading the partial or the full task to the cloud or to other servers so that the edge device can remain unconstrained and reduce the battery usage and in turn improve the energy efficiency. The computation are not required to be offloaded entirely to the servers or to the cloud. Therefore, the partial offloading is becoming one of the most common offloading technique. And further, to minimize the energy usage, the optimized offloading using AI or machine learning can be deployed to offload the computation based on the resource or the network constraints. Another big problem is the energy waste and the inefficiency of the edge hardware. To overcome this, many companies are moving towards using the SoC design to combine the components to save the space cost and also improve the power consumption. Additionally, a domain-specific system on a chip can also increase the energy efficiency of specific domain computation by orders of magnitude compared to the general processor. So besides the processor, the nano flash memory is the latest storage technology in the edge device due to the non-volatile storage, and it does not rely on power to store the data. In addition, the new generation Bluetooth chips and ultra-wound chips and any other chips can also bring the low power consumption and provide the high bandwidth for the network access. Besides the hardware, there are also many software solutions to improve the energy efficiency on edges. For example, both the Android and iOS they provide low power mode functionalities. For the iOS, it utilizes several power-saving technologies, including intelligence application management and task priority and other tools. So algorithm, along with operating system, today provide a more important role in overall edge efficiency on the edge platforms. Last but not least is our vision and the future directions. So the higher energy consumption on the edge not only consume lots of waste of the power and make our system operation unstable, but also it harms the environment and also the social security. So the energy consumption management on the edge computing platform is still in its early stage. So there still exist many problems need to be further studied. So we propose several directions worth of future research, including first, using the virtualization on the edge to save the energy, and second, collaborative energy management across different nodes, and third, build a more accurate management and modeling for the energy consumption, and last but not least is provide a personalized or customized energy saving on the edge computing. So this is all of our presentation. So if you have any questions, please send emails to the following authors, and thank you for your time and attention.